Hi folks, Bollinger here. I'm going to be your Algebra 2 teacher. And this video is a little introduction to what you're going to experience here this semester. And I'm doing it because I teach very differently than mainstream instruction. I've been teaching math for 44 years. My first 10 were, generally speaking, done traditionally. For the most part, I always sent students to the board. That was different back then. I had a colleague who put a few folks up at the board. I put the whole class at the board, and you'll basically be completing worksheets. So you're not sitting down, you're up, you're talking, working with each other. Hopefully you'll have some fun. I want to have some fun. But math is a language, and our goal is to gain fluency. I'll give you an example of language here. So let's say Spanish for, well, maybe a lot of you speak Spanish. How about it's Russian? How do you say desk in Russian? Okay, and a lot of times people say, well, math's all about problem solving, so I just gave you a problem to solve. Go ahead, solve it. How do you say desk in Russian? I don't know either, right? And I'm not going to know unless somebody tells me. And that's what your experience is going to be like. You're going to be encountering different algorithms, 10 to 12 algorithms. In Algebra 1, probably encounter just a couple, linear and quadratic, maybe something else, I don't know. And that's not how I teach. My Algebra 1 classes, I teach all the algorithms that you're going to see at high school level, except integration and differentiation and calculus. But I certainly, some students, even at Algebra 1, get a chance to talk about some of those concepts. And maybe you might be one of those folks this term, because you're going to work at your own pace. There are 3 stages to learning: following, doing it yourself, and explaining it to someone else. And I hope all of you have the experience of explaining problems to each other. Really forces you to sort out concepts. I know how to do that, but how do I explain it to somebody? Really solidifies what's going on. And my job is to always add layers to your understanding. So depending upon where you are at any moment, our conversations are going to be different in one individual to the next. So, holistic experience in this class. I'll give you an example of holistic experience that I had and didn't realize it was one until partway through the course. And it was one of my sabbatical years. I was down in Mexico. I can't remember the instructor's name. The head of the language program, written a lot of textbooks. He had a lot of language classrooms scattered around Mexico. San Miguel de Endo, I think. San Miguel de Endo. I hope that's the name of the town that we were in. And we did about 4 days of intense language experience. And I think at the end of the 4th day, I went, I can't deal with this. There's too much coming my way. And then the instructor walked in about 2 minutes later. He said, right about now, you're probably frustrated. And I went, yeah. And he said, don't worry, we're stopping right now. And we're going back over everything you've done. And we're going to continue to work with it for the entire remainder of the time that you're here. And I said, it's not exactly what I do, but it's pretty darn close. And so I understand the frustration level when you're overloaded. And I'm saying this to you because I'm going to overload you. I'm going to give you an awful lot of material in the first 2 or 3 weeks. And I don't expect you to get it all right away. But I think learning a language is all about repetition, and math is a language. I'll give you an example of how it's a language here. Let me give you your first experience with learning something. See if I got a marker here. So you get to read this sentence. The value of the exponent that you put on top of 5 to get it 25 is a 2. I'll find a marker. And while I'm doing that, you tell me what I should write, because if we study math by writing it out that way, hey, we're in a lot of trouble, because that took me too much time to write. And if we're going to try to, study the world, which is what math does, it allows us to look at relationships in the world and say, hey, you give me this, this is what we start with, and this is what we end with. How did it all happen? Well, math is what explains that. It's what puts people on the move. All right, so the value of the exponent you put on top of 5 to get 25 is a 2. And I'm guessing, since it's now Algebra 2 class, and most of you said 5 squared equals 25. Okay? And that's logical. That makes a lot of sense that you'd say that. But guess what? It's not what I wrote. Not what I wrote. Okay? So the value of the exponent, that's a concept. Right? The value of an exponent. So we got to write that symbolically. And the way you write that symbolically is log. Short for logarithm. Okay, so now your brain, next time you see log, you know, if we're going to do it every day for the rest of the term, you're going to see this type of problem every day on every test. Not going to spend a lot of time on it. That's the holistic process, is to, you know, look at something briefly every day, but work with it every day. And I think that repetition is how you build understanding and foundation. So the value of the exponent log that you put on top of a 5, well, the 5 goes there because, you know, 5 squared, it's a base, right? So in that position, it's a base. To get 25, value of the exponent, you put on top of a 5, you get 25, is equals 2. Sometimes an equal sign is better understood as maybe written as. You know, 3 plus 4 may be written as 7. And that's one of the main things we do in math is we simplify. It's easier to say 7 than 3 plus 4. My definition of simplification is strokes of the pen, fewer strokes of the marker in this case. So that's a simpler way of saying 3 plus 4. Okay? So the value of the exponent, you put on top of a 5. To get 25 is a 2. Now, what we're going to learn is to rewrite what's in the parentheses in terms of the base. 25 is 5 squared. And so what's the exponent put on top of 5? Well, there it is. The 2. Your first lesson. Now that took 2 minutes. In our first class, I'll probably throw a logarithm up there. We got to develop more understanding of exponents because there are 3 things that happen exponentially. So next lesson, I might as well stick with this for a moment. Give you just a brief lesson, maybe 4 or 5 minutes here, and then get back to explaining more about the class. All right, so what's a quicker way of saying m times m times m? From Algebra 1, you should know that that's m cubed. Hopefully you're coming in with that knowledge. So what happens when we divide by m? Well, if we do 2 times 2 is 4 times 2 is 8, divided by 2 is 4, then we can see that 2 goes into 2 once, and 1 times 2 times 2 is 4. So it's really m to the 3 minus 1, right? Because we're really, we say canceling. Well, it's not really canceling. It's dividing something by itself, which gives you 1, and that multiplication disappears. So we have 2. So what would it be if we put another one there? Well, I hope you see that we're taking away 2 from 3. Okay? And so therefore, if I erase the 3, m times m to the minus 2, negative exponents really tell you how many times something's a factor in the denominator, but we'll come back to what we started with. Okay, so 2 of them divide out to be 1 times m is m. So 3 minus 2 is 1. And we don't have to write the 1, right? We never write something we don't have to, it's understood. And then if we put another one there, well, then it's 3 minus 3, which is actually m to the 0, which you should have worked with in Algebra 1, but you may not have understood why something to the 0 was 1. And just because I put it up here once doesn't mean you picked it up right now. But I'll keep saying it the whole term until you do pick it up. So anything to the 0 is 1. And another aspect of this course is based on 0s and 1s. I'll give you an example of how nice the numbers 0 and 1 are in terms of calculations. So would you perform the following calculation, please? 5.394 times 7.21. And I want you to give me the answer in under 10 seconds without a pencil. 5.394 times 7.21. Oh, I don't know either. Right? But how about 5.394 times 0? Oof. 0. How about 5.394 times 1? 5.394. This course is based on zeros and ones. I've made my own course, by the way. Okay, and some of my own algorithms. I don't know, at least one of them is. All right, so now we've got negative exponents. So what's 5 to the negative 3? 5 to the negative 3 is 1 over 5 times 5 times 5. That exponentiation is, that multiplication is in the denominator, so 125. Okay, so now we know what a negative exponent is. Maybe, I shouldn't say we know. A seed has been planted. I have a rule of 4. I never worry about anybody until you've seen something 4 days in a row. The only problem with that is you're not used to that kind of instruction. And if you don't get something the first day, you start to panic and anxiety sets in. And I'm telling you, put a smile on your face. It's a whole different experience here. Okay. Why do I do it? Okay. Why do I do it? Here's the classic Algebra 1 problem. 2, 7, 8, 23. Write the equation of the line that passes through those 2 points. Now, why did I put that up there? Because I'm guessing you can't do it. Right? And that is a problem because every level of mathematics is based on the previous level. And this is something you should be able to do in 10 seconds or less. My experience has been, it'll take you 4 days to learn how to do it. It'll take you 4 weeks to be able to do it in 10 seconds or less. And you're going to get that amount of time because I don't give any test with a percentage score. Last time I taught Algebra 2, well, it wasn't maybe the last time, but the one situation that comes to mind for me is that a young lady, very bright young lady, picked up things very quickly. And I think after 2 weeks, I asked 45 questions on a test, and I think she got 32 out of 45. And that was the best test score in the class. And I'm looking at that going, hey, that's an A+ student, or at least an A. I mean, she's learning at a great rate, and she's looking at it as a percentage score and thinks she's failing. Okay, so it took her a while to get used to the course. And her final exam, she got 101 right out of 102, and she did it in 45 minutes and left with 45 minutes to spare on the final. And we had gone way past Algebra 2. And we were already doing sinusoids and talking a little bit about calculus, right? Because she was capable of it. So you're going to get to learn at your own rate, and you won't get any percentage scores, but you're going to tell if you're learning by each successive test. All the material that was on the previous test is on each test plus a little more. And you'll be like a dog, you know, and the tail wagging is what you're learning or what you got in your pocket. And you're still hitting new and new material. Okay, so you're always going to be hitting new material until I put the brakes on, like my Spanish instructor did. And when I heard that, oh, the brakes are on, I was really happy. And I had a great learning experience. Okay, so no percentage scores. But you'll know if you're learning, like whether your scores are going up and at what rate. And if your neighbor's scores are going up at a great rate and yours aren't, well, maybe you need to work a little harder. And there is, you know, you got a lot to say about how you want to go up the ladder in this course. But as long as I see scores going up, I'm happy with it. Okay? And you'll be fine in the class. You just don't want to get stuck. I can only get 3 right. 2 weeks later, I still only get 3 right. Well, then we got to try different instruction, and I can tailor it to your needs. Okay. But by and large, first 3 weeks are the toughest. And then it's usually fun sailing for the remainder of the semester where we get to really explore some things from what? Geometric, numerical, graphical, and which one did I miss? Numerical, symbolic, perspectives. Okay, so we're going to look at things from a variety of perspectives. And, you know, we can call it Algebra 2, but it's really what you can do with a rectangle. That's a language, right? Linear. It's a line. You know, how long is it? Quadratic. Quad, 4-sided figure. What's a rectangle? Right? Side length to area, X to Y. Okay, planting a seed here. Cubics. Studying volume. Oops, I went the wrong one there. Okay, so math has origins, geometric origins. You know, people were selling land and they had to figure out how much to sell it for. Square area, right? Square foot. We still work with that language today. And that language is embedded in mathematics. So got to tie it to geometry. Okay, how did math come about? It evolved. How did it evolve? Well, it started somewhere. What do you think it started with? Well, you're probably saying addition and subtraction. Feel free to pause the video at any time and think about it. Okay, I'll give you my thoughts. You know, somebody put a little mark on a cave wall. Math is born. You know, and then somebody probably did addition and subtraction, and then multiplication and division, then powers and roots. We already did some powers. We didn't do the roots yet. Well, there's your next lesson. Here's 5 squared. Going back to what we said a minute ago, 5 squared. Okay, 5 squared is 25. We know that. Okay, so what happens if I put a 2 there? I just canceled squaring. If I canceled squaring, then that's a square root. Okay, something new. All right, so why do I say that? Because we got to be able to handle problems like this, 4 to the negative 3/2. Right, there's 3 operations there. There's the minus sign, which means something. There's the cube, which means something. And there's the 2, which we now mean something, square root. And it doesn't matter what order you do those in. What do you know? You know what 4 to the 3 is. 4 times 4 times 4, which is 64. Okay, so that means I did the 3. So that means I have 64 now to the minus 1/2. We just said square root. Well, what's the square root of 64? Square root of 64 is 8. 8 to the negative 1. What's 8 to the negative 1? 1/8. And that's going to be on every test the whole year, the whole semester. But what's the beauty? You get to figure it out at your own pace, because I'll have those problems now on your first worksheet. And you get to go to the board, and again, I don't worry about you till you do it 4 days in a row. All right. Now, the beautiful thing here is, I said the order doesn't matter. So what's the quickest way to do that? Well, you can do it in your head. Most of my students can do it in their head after 2 or 3 weeks of practice. On day 1 or 2, they're panicking. Okay, but let's look at this again. 4 to the negative 3/2. Well, I think it's easier to do the square root first. What's the square root of 4? 2. Well, there's 2 to the negative 3. What's 2 to the negative 3? 1/2 cubed. Okay, well, there's your 1/8. That's what this class is about. All right, lots of problems. Go to the board, do the work, and we try to gain fluency. Why? Because maybe you want to be an architect, maybe an astrophysicist. None of those jobs are open to you if you don't have fluency in mathematics. And you're not going to have fluency in mathematics unless you do it repetitively. How do I know that? I can tell you experience 3 years ago in a pre-calculus class. 32 students. I gave a review, and I also did some sinusoids, the unit circle, which was new. But that was only 5 or 6 problems of the first test, which was 45 questions. After 2 weeks of review, how to write the equation of a line, how to graph a linear function, how to graph a quadratic, all the stuff they should have learned in Algebra 1 and Algebra 2. And after 2 weeks of review, the average score, the median score on 45 problems was 9. 9 right answers. Okay? Not acceptable. That's not fluency. Fluency is, oh, I think I gave you how to write the equation of a line, huh? Back here. Fluency is based on zeros and ones. Well, how do I make the number 2 a 0? I subtract it. Okay, it's gone. And I want that x to get me a 7. Well, there we go. That takes care of this. And then slope, which is all about change, how things change. Well, how did this linear per parentheses change when I put an 8 in? Well, that's 6 units of change. All right, well, I'll write it here. 6 units of change plus the number 7 does not take me to 23. So I get rid of it. I get rid of that change with a little division. I cancel it out. How do I get from 7 to 23? I got to go up, what, 16? Of course, you can reduce that, but that's writing the equation of a line. Now, my students can't do that the first time I show them. I have to do that for a while. But by day 4, most people are kind of plugging their way through and getting it right. And then by midterm, that's 10-second problem. And that problem morphs into the quadratic, which can be written just as quickly and easily. Exponentials, there is nothing that we can't do basically in 10 seconds or less. Exponential, logarithmic, sinusoidal. And I want you to learn how to do that. It's going to take some effort, but if you work every day and you really think about it, the mechanics usually take about 4 days. Okay, doesn't matter the age. Okay, done that with 6th and 7th graders. Okay, so I'm hoping that we have some fun. I'm hoping that you're anxious to learn how to do that because it's going to benefit you. SAT scores are going to go up and some doors are going to open up if you put the effort in. That's your job. And I'm here to help you succeed in that job. That's my job. And I take that job very seriously. Okay. Of course, it's not based on a lot of homework, but I will because I'm only teaching one class this semester. I'm semi-retired. I can make videos. And so can't do a problem. It's all right. I'll be doing it in the video. And then all you got to do is write it down so I know you looked at it. All right. That's basically how we're going to go through with homework. So what else have I said here? I got some notes over there. See if I missed anything. I don't think so. I think just looking forward to getting to meet y'all, find out where you're coming from. We got a young man who's going to join us from overseas on the class. I'll introduce him to you on Wednesday and talk about him coming up on Monday. And I think that's probably it. Okay, so I'm going to try to really, if you're looking at this, then you obviously know I got a YouTube channel with all kinds of videos on it. Some of them are definitely going to be appropriate for us to be looking at. I think they all are actually, but I am going to try to put some order to this particular class and record it as we go along so that there's something that hopefully become user-friendly for you. You can go back and look at something if necessary. And I'm just interested in doing it just as a project for me. Right? So I want to record our Algebra 2 session chronologically, what introduced to you and at the pace, and we'll hopefully have a good time together. All right, so I'll be meeting you soon, and I'll upload this, and hopefully you come in with questions. Okay, and no percentage scores. It's all about going up the ladder. Okay, show me you've learned something new, and there's 3 or 4 things in front of us already. There'll be about 12 to 15 after day 1, maybe 30 after day 2, and you chip away at it, start putting some of those in your pocket. All right, see you soon. Bye-bye.